Good. All right. Thank you for tuning in to this episode of Down at the Dock Mod Edition. Today I'm going to go over the house battery upgrade that we did on channel surfing. I've been saving this topic for last, as the battery monitor and the solar panel upgrade I actually feel are more important upgrades. We'll talk more about those in a bit. In this episode, I'll provide an overview of the house battery bank upgrade, including my thoughts about why I chose Firefly batteries over Lithium batteries, as well as over other brands of AGM batteries. I will also go over what was involved with the installation. I'll answer questions as to how long did it take to complete, what I purchased, where I purchased them from, and lastly, how much did I spend. We have a lot to cover, so let's get started. Alright, first thing to talk about is I didn't want to upgrade my house battery bank. I had to, right? And the reason I had to was we took delivery of our boat in June of 2020. By October of 2020, our house battery bank wouldn't hold a charge. Episode we published in October of last year of us going down to Des Moines, where a buddy of ours, Tony, was taking delivery of his new R27 outboard. So we're going down to meet with him. We got stuck in some 3 to 5 foot seas, got tossed around for a couple of hours. We ended up across the channel in some calm water, anchored for the night because we couldn't get into the Des Moines marina. That night on the hook, I got 60 minutes on my house bank and it went to dead. And I was like, I want the heater running and I need the anchor light running. Fortunately, at that time, I had upgraded to the battery monitor a couple weeks before, and I'd also put in a combined switch so that I could combine my thruster bank with my house bank in an emergency, and therein lies my emergency. So we actually survived that night on anchor with the thruster battery combined with the house to run the heater and the anchor light. So by the time we were done with that, the next morning we ended up in the Des Moines Marina. It's the factory dock, so I had the factory come down and take a look at the batteries because they were still under warranty. And they put a tester on them. They seemed fine, but when they were looking at them, a couple of the battery lugs had come loose on the terminals, right? So we figured, loose connection, that's probably the root of it, because that'll certainly cause your batteries not to work right. So I tightened up all the connections, figured everything was fine, and had a great weekend and headed home. Well, it still didn't feel right on the boat, so a couple weeks later, I was sitting at the dock and I was like, let's just test the batteries. And I don't know of any true way to test a deep cycle battery. Those little tools that you use, the little gauges, whatever, that they test cold cranking amps. They're meant for like engine starter batteries. Deep cycle batteries give off a little bit of current over a long period of time, as opposed to a cold cranking amp battery that's a lot of current, short amount of time to start the engine. So we just sat down the boat and disconnected from shore power, and I ran about 10 amps worth of stuff on the boat, just normal things. You listen to the radio, the Garmin chart plotter was on, disconnected from shore power, and it took all of 60 minutes on the nose to go from 12.8 to 10.5 volts. So I ended up testing each individual battery, thinking, which one of them is bad? They both were bad, right? So the factory had offered to replace them under warranty. I declined. My comment was, I did this myself. Give me new batteries. I will do it again, right? So I was like, I need to do something differently. When we, how did we sulfate and destroy our batteries so quick? We would do things like, shrimp season would be up and we'd take off on Friday. I'd go shrimping Saturday, Sunday, it was a special opener they had, I remember, and so we were 2 days at sea, basically at anchor. I was running the engine every day, right? So I figured that'd be enough to charge the batteries. It wasn't, plus we were putting our shrimp in the freezer, freezing it overnight. I remember getting up, going to the head at 3 o'clock in the morning when I flushed the toilet, the lights dimmed, and they're LED lights in the bathroom. I was like, ooh, that's a red flag. So I go turn on the chart plotter, and I was down to 11.3 volts, whatever. So I idled the engine for a bit to recharge it, but we were constantly getting the 10.5 or 11.8 volt warning on the Garmin. So we thought we were conserving on electrical, and apparently we weren't. So there's other times we'll say we'd be up using the windlass to retrieve the anchor. I'd have the engine idling, and then all of a sudden all the electronics would just start rebooting, right, due to low voltage, right? The windlass put such a heavy load on the system, it comes right off the house bank, and it was enough to cause the Garmin and the VHF radio to reboot. So anyhow, I knew I needed to do something different. So why did I pick Firefly batteries? Well, actually, let me answer the other question everybody's asking, and that is, why not lithium, right? Why did I rule lithium out? So, lithium batteries are a different battery chemistry than AGM. AGM and flooded lead acid battery are very similar, but lithium is way different. So to do lithium, you have to isolate your house battery bank, and you have to think about all the charging sources on the boat. They all have to support lithium. So that's your engine charging, your shore power charging, and your solar charger all have to be able to support lithium. Right, and if they don't, then you have to replace those components. For example, the boat comes with 2 ACRs, automatic charge relays. In English, all they are is an automatic parallel switch. Right, those ACRs let you parallel your engine in your house and your thruster battery for the purposes of charging them. Well, one of the requirements for an ACR is to be the same battery chemistry on both sides of it, because it's just a parallel switch, right? So I would have had to pull the ACRs out, put DC to DC chargers in place. The solar charger would have to support lithium. It'd have to be replaced. The battery charger would have to support lithium. The battery charger that came with the boat was a 20 amp battery charger. It actually does support lithium, but only on bank number 1. Bank 2 and 3 don't, which actually would have been fine. I could have made that work. It was just way more complicated and a lot more components to have to get replaced, in addition to having to change out the batteries. Right, so overall, that would make the whole project for lithium more expensive. The batteries are more expensive, all the other components are more expensive, the work would have been a lot more expensive, and then enter an AGM, they're a drop-in replacement. The boat was already designed for AGM batteries, right? So the one thing that I did have to do, and this is true whether you upgraded to Firefly batteries or to golf cart batteries, if you're increasing the capacity of your battery bank, you have to increase the capacity of your battery charger. Right, Fireflies require 20% minimum charge rate. Non-Firefly AGM batteries, 10% is the minimum. That's the AVYC standards, is 10%. Right. So the Fireflies, for the same battery, they're 20% more capacity as compared to a conventional AGM. So let's talk about why I picked Firefly over a conventional AGM. 20% more capacity, as I just said, for the same battery. I can take that battery to 0 and it will recover. All right. I've been as low as a minus 299 amp hours consumed out of a possible negative 348. That's about 12-13% state of charge. And the batteries recovered just fine from that. Also, the Fireflies offer a longer lifespan over AGM. They are technically about as close to lithium batteries as one can get without actually going lithium. Firefly batteries, actually, it's interesting what they were designed for. They were invented, I want to say, it's probably been like 15 years ago-ish, maybe 20. They were designed to solve a specific problem, and that was mainly in the trucking industry. Trucks go cross country all the right, and they run their air conditioners. They've got a microwave, a little camper canvas or camper in the back where the truck drivers sleep and the rest stops and stuff. And there were some issues with certain cities and states and whatever. Supposedly were restricting them idling their engines while they're running their engines all the time, 24/7. So they needed to be able to run off of battery when they're not actually driving, have to turn the engine off. That's what they were actually designed for. But for boats, they're in my opinion, a perfect fit for how they operate. So they are more expensive than AGMs, but cost-wise, they're less expensive than lithium, And lifespan wise, if you look at the cost over time, the Fireflies would be less expensive than, say, AGMs for the same time frame. Because AGMs you'd be replacing a lot more often with the Fireflies, and you're going to get more usage out of the Fireflies. All right. So I was looking at drop-in replacement, easy to work with. If I make a mistake and take them too low, I can recover and I won't have to be buying new batteries again. All right. So relocation of batteries. Why did I move the batteries from the Port Lazaret to Centerline? So number one reason was balance of the boat. Our boat had a pretty severe port list. We've got the 9.9 kicker on the port side. We've got the cockpit refrigerator on the port side. The boat came stock with 3 batteries on the port side. It was 2 house and a thruster battery there. So the boat just naturally listed to port. So if I could move some weight to Centerline, I thought that would help. It also would make it easier access to the batteries. All right, let's take a look at what we're working on. That's not stock. A lot of people asking when I did 2 Fireflies, why didn't I do 3? And I thought about that a lot. And actually, what I come to realize is you can put a shelf across that. It was a great idea that Mike gave me. So I decided to put a shelf there, but if I put a shelf there, I'm going to be looking at this spot right here and say there's a piece of storage space that I can't use. Why didn't I put a battery there? So I put a battery there. So now we have 3 Fireflies. You know, I will note that you can actually fit 3 Firefly batteries in the Port Lazaret. I know of one other Ranger Tug owner who has actually done it. Talked to him extensively about it. So it is possible if you don't want to give up the center Lazaret storage, and you want to keep your batteries in the Port Lazaret, you can fit 3 Fireflies in there. Basically, do your thruster, your 2 house batteries, all as Fireflies. You could do that. I wanted to move to the Centerline. Like I said, the balance of the boat was more important to me. Why did I use 4/0 cable when I moved the batteries? In electrical, there's no penalty to go up on size wire of stuff. I mean, it adds weight to the boat, and it adds cost, right, at the store to buy it because it's more expensive. But I was looking for as little voltage drop as possible from the extra cable that I was adding. That's why I did 4/0. So I basically just threw money at the problem. So the bus bars. Why did I do the bus bars? I did a 250 amp bus bar and a 650 amp bus bar. The reason I did the bus bars was all the cabling in the boat that connected to the house battery bank all lived in the Port Lazaret. I didn't want to have to redo all of those cables. So there's like a dozen of them. It's the ACR cables, the inverter cable, the house loads cable, all of that stuff. Was all cut to length to fit the Port Lazaret. So where the 2 house batteries are, that's where the bus bars are. So I removed the batteries, replaced it with bus bars, and then re-terminated the cables right to those bus bars. That made it a little bit easier. The other reason was with the bus bars in place, that then allows me to connect the 3 Firefly batteries in parallel and connect them to the boat. So if you figure I have battery 1, 2, and 3, the positive to the boat comes off of battery 1. The negative to the boat comes off of battery 3, right? And that's important because that forces all those electrons to go through the entire house bank equally. That means my 3 batteries will operate together, they will wear out together, and each battery will participate nearly equally throughout their lifespan, right? So that was pretty important to me. So why did I do 650 amp for a positive bus bar and a 250 amp for a negative? Kind of a funny answer here. The boat comes with 175 amp fuses, so I thought, as long as I'm at 175 or above, I should be fine. So I went shopping Blue Seas bus bars, looking at what they had available, and they had some 150 amp bus bars. Those had quarter inch 20 studs on them. That's too small. Then I looked at the 250 amp bus bars, and they were 5/16 studs. Okay, that was good because 5/16 is what the negative lugs on the boat actually were. And then the 650 amp bus bar was 3/8 inch studs. So I picked those based on the stud sizes to match what the battery cables were that came with the boat, right? There's been an old standard. I don't even know if it's a standard or not, but I've seen this before where negative is usually 5/16 and positive was 3/8. And I guess the idea was to keep you from mixing the two up, right, on accident. However, like the Firefly batteries, both their positive and negative studs, you know, are 3/8 inch. But that was why I did the 650 and 250 amp. It wasn't the amp ratings. As long as it's above 175, I figured it would be beefy enough. But I wanted the correct stud size to match the battery lugs for all the cables that I was reconnecting. So the cost of the upgrade, what did I spend on this, right? So I'll just tell you right now, this was the most expensive upgrade I've done on the boat, was the battery upgrade. And the reason for that was I had to get 3 batteries, a battery charger, and all the wiring and stuff to cable everything together, and all the time it took to do all of that. The 3 Firefly batteries, just the 3 of them, was $1,700. They're a little over $500 a piece plus tax. I bought them from Fisheries Supplies in Seattle. They're a local distributor for them. You know, Fireflies, you got to go to their website to find out who nearby you has them. Shipping is over $100 if you, per battery if you try and get them on Amazon. The relocation components, the wire I needed, the battery boxes, the battery lugs, the bus bars, etc., was about $1,000 total. The bus bars were a good part of that. They were pretty expensive. And that was bought, some of it was bought at Harbor Marine in Everett, the rest of it was bought at Fisheries Supplies in Seattle. For tools, I only had to buy 2 tools I didn't already have. So that's to be able to crimp 4/0 lugs and lower. I start out with a hammer tool. It's just a little device, so you put the lug in, you beat it with a hammer. I didn't really like that. I used it on the first upgrade when I did the 2 batteries. And what I didn't like on that was I'd get everything set in the boat, cut it to length, then I'd have to take it off the boat and beat it on the dock with a hammer, because I'm not beating that on my fiberglass boat to crack the fiberglass. So it was a lot of get on and off the boat. The hydraulic crimp tool meant I didn't have to get on and off the boat anymore. I could do all the crimping inside the boat. It was much more convenient. That little hammer tool I bought was Fishery Supply for like $25, I think is what I spent for it. The hydraulic crimp tool I ended up getting off of Amazon, and I want to say it was like $50, $60. And it'll do 4/0 and smaller cables. But either one makes a decent crimp for it to work. Let's see. It was definitely a full day's worth of work to do the battery upgrade, probably a day and a half, I would say. And then because I was increasing capacity in the house bank, you have to upgrade the battery charger. Do not forget to upgrade that battery charger if you increase capacity. So looking at the battery charger on the boat, it came with a 20 amp Kaisi ABSO battery charger. So I looked at replacing that. They make a 40 and a 60 amp version of the same battery charger. They're about, I want to say it's like 1.5 or 2 inches longer than the 20 amp, and I didn't have the space to put that in my boat. The 100 amp that they make would have been really sweet, but it was not only longer, but it was also deeper, and the scuppers on my boat would have gotten in the way. So there was no way I was going to be able to pull the 20 amp out and put something else in its spot. The spot that it's in is just not big enough for anything other than the 20 amp battery charger. So I went looking around the boat and said, where else can I put a battery charger? So I found a spot on the port lazarette all the way aft. I was like, I'd have to build a shelf to put it there, and because of where it's at, it'll get wet on occasion as I wash the cockpit and stuff down. So I wanted it to be waterproof. So that's what landed me on the Skyless 70 amp battery charger. So that was another $800-ish for it. I bought it on Amazon. Because of where I was putting it, the LCD display on the Skyla wasn't going to be easily accessible. So that led me to have to go buy the Servo GX. For whatever reason, Victron does not do Bluetooth or anything in their Skyla battery charger. But if you connect it to the Servo GX, then I could wirelessly connect it, and now I could access the configuration and the statistics of the battery charger through the Servo GX. One correction I'd like to make is if you've if you've watched the video already on the Skyla battery charger install, I highly recommend that you do that. If you haven't, in there I specify an 80 amp fuse on the DC side because it's a 70 amp battery charger, so I put an 80 amp fuse on that connected to the bus bar. Don't do 80 amp, do 100. So funny story here, we left the boat for 4 days at the dock, came back to check on it. I open up the door and I see the battery monitor is lit up, and Lizina tells me she can hear the beeping, that it's alarming. And I look at the stats on my phone and I'm at like 12% state of charge. I look at the Skyla on my phone through the Servo GX and it says it's in storage mode. So I'm like, so the Skyla doesn't think it has any work to do, and yet my batteries are almost dead. I was down 299 amp hours out of 348. So troubleshot it and found out that I'd blown the 80 amp fuse. So I went back and I was like, well, if voltage goes a certain direction, it's actually possible to get 80 amps out of a 70 amp battery charger. So I was too close in the safety aspect of that. So I ended up swapping out the 80 amp for 100 amp fuse, and that fixed everything. And then I went and fired up the 20 amp battery charger with the 70 amp, and it recharged the Firefly house battery bank, and we've had no problem since. It all recovered. Had these been normal AGM batteries, I'd have been buying a new set of batteries over that mistake. All right. So talk about the Servo GX for a minute, because this actually turned out pretty cool. So the main reason I bought the Servo GX was just simply remote control of the Skyla battery charger. Because it's a 70 amp battery charger, it can pull upwards of 10.5 amps from shore power. So if I plug into a spot on shore that only has a 15 amp circuit, I need to be able to tell the Skyla, don't pull 10.5 amps, pull 5 amps, pull 6 amps, something smaller so that I don't trip the shore power breaker. So that was the reason for the Servo GX. But since I had it, it's actually meant to tie all the Victron stuff together, right? So I ran a VE direct cable from Victron between the solar controller and the servo, and I ran one between the battery monitor and the servo. And then I told the servo, because it's wireless, it's actually Wi-Fi, and I connected it wirelessly to the Garmin chart plotter, which broadcasts a wireless signal as well. And now, when I'm driving along, I have a Victron app that shows up on my Garmin chart plotter that I can see the stats from solar, I can see the stats what the boat's consuming, I can see the stats from the shore power charger if I'm plugged into shore power, all on the Garmin chart plotter, which is a really nice to have. I wouldn't say that's required. And if anybody says, do I need a servo, I would probably say no. I needed it primarily because of the Skyla battery charger, but I also will tell you it is a really nice to have to be able to see the effectiveness of solar and what the house is normally drawing on the Garmin chart plotter, especially when I'm underway. Installing of the Skyla 70 amp battery charger is a full day's worth of work without question. Right, you've got to connect it to the AC panel and then connect the DC side to the batteries. So the benefits of the upgrade. I've more than doubled the usable capacity of my house battery bank. I expect to get at least 10 years from these batteries, maybe more. If something happens and I run the batteries down to 0, they will recover. I've done that, not on purpose, but it worked, right? The 3 batteries also help out a lot with heating hot water. So obviously with the outboard, hot water is the panacea because we don't have any engine raw water to run through. We don't have any engine hot water to run through the hot water tank like you would on an inboard. All right. So the only way to get hot water is through electric. That hot water tank pulls 65 amps at 12 volt DC, which is a really heavy load on the boat. And what really makes it heavy is it needs to run for half hour to an hour, depending how much hot water is left in it, right? So it's running it for that long a time. The 2 AGM batteries that come with the boat, I would tell you, don't heat hot water off of the 2 batteries that came with the boat. What I do is I time hot water around the sunshine. When the sun comes up and is beating in overhead, usually around 10:30, 11 in the morning, I'll look down on my phone and say, oh, we're getting over 20 amps of solar right now. That's when I'll turn around, I'll go fire up the inverter, and I'll turn around and I'll idle the engine. I'll bump the RPMs on the engine up to about 1100, so it's just a little bit above idle. That'll give me about 30 amps coming in from the engine, over 20 amps coming in from solar. That's 50 amps out of 65. That leaves me 15 amps short for running the hot water tank. So then I've got 3 batteries to share the 15 amp load between. So that means each battery technically only has to give up about 5 amps. So now the batteries aren't working nearly as hard, and I'm using solar and engine to heat the hot water, and usually within 45 minutes-ish or so, maybe as much as an hour, the hot water tank will be fully hot. I will know that because the battery monitor will show me the load drop off. Instead of it, pulling 65 amps, it'll drop back down to 10, whatever is normal for the boat. All right. With the battery bank, being 2.5 times larger than what the boat came with, I could easily do 2 nights overnight, probably 3, and that's assuming like in the middle of winter when solar is not nearly as effective. I was thinking, on sizing the batteries to get me through a couple of nights during the off season, because during boating season, I can tell you, I don't think I would need my large battery bank during boating season with solar, with the exception of the hot water. That would be the real reason to do it, but to help out with getting hot water. But if I didn't need the hot water, solar power, I wouldn't would make up for any shortcomings of the house battery bank. So if I had to do it all over again, would I do anything different? Yes, I would, right? So if I had to do it all over again, I would have installed the battery monitor first. Why? Because that's the gauge. That's what tells me what's going on. I would have known that my batteries were getting low before they were destroyed, right? I remember getting up at 3 o'clock in the morning to use the head, and when I flushed the toilet, I watched the LED lights in the bathroom dim. Right, that is not a good sign. I go out, and sure enough, my batteries are down to like 11.5 volts or whatnot, and I was back idling the engine to try and recover from that. Right, so a battery monitor is very instrumental in letting you know the actual state of your batteries. The most important thing is let you know if you're going to go to bed, do you have enough batteries to get you through the night? Right, so I would not have killed my batteries like I did had I had the battery monitor. The next thing I would have done different is after the battery monitor, I would have upgraded solar, because it's highly likely that with solar, you may realize that you don't even need a bigger house battery bank. The key thing to understand is the battery bank is a bucket. It holds electrons, but when it's empty, what happens? You've got to restore it somehow. You've got to get back to shore power, idle the engine. You got to put those electrons back in that bucket somehow. So solar panel effectively is our generator, right? And in the summertime, it's immensely effective. Right, this was the most expensive and time-consuming of all the upgrades that I've done thus far. The work is all electrical, it's all tedious, it's very time-consuming, and it's certainly at all not inexpensive. Right, so if I go back over the cost and look here, so try and add all this stuff up. $1,700 for the 3 batteries, $1,000 on wires, bus bars, battery boxes, lugs, etc. Heat shrink tubing all falls in there. Call it another $60 for hydraulic crimp tool, $800 for the Skyla battery charger. You've got another $500 worth of cables and heat shrink tubing and fuses for the battery charger install. And that includes making a shelf out of that. The Servo GX was another $250 to put that in. And then time-wise, it's probably a day and a half-ish, I'd say, for the Firefly battery upgrade. It's another full day for the Skyla. Servo GX is probably another half day. Right, so it's certainly all the solar upgrade is less expensive, and in my opinion, you get more out of that right away as well. And like I said, you're probably going to end up at solar anyway. If you're not running a generator, and we didn't want to run a generator on our boat, so if you're going to end up upgrading solar, do it first, and then that would help you size what size battery bank you need to go to. Maybe you don't need to upgrade to 3 batteries, maybe you only need to upgrade to 2, maybe you don't need to upgrade at all. So again, I want to thank everybody for watching. If you really enjoyed this video, please consider subscribing to our channel, as it really helps us out a lot. If you have any questions, please leave them in the comment section below, as we really do love hearing from each of you. And until next time, stay tuned for more channel surfing.